Welcome. Today we are going to learn a concept called constant of integration. As we know, derivative of constant always zero. Derivative of constant with respect to x is always zero. So, if we take derivative of sin x, it is cos x. Sin x plus 7, as it is addition, derivative of sin x is cos x, derivative of 7 is 0. Therefore, derivative of sin x plus 7 is a cos of x, or sin x minus 13 has also derivative cos of x. As a integration is a antiderivative by definition, cos x is the derivative of sin x, therefore integration of cos x is a sin x in first case. Second case, cos x is the integration of a derivative of sin x plus 7, therefore integration of cos x is a sin x plus 7. And last case, integration of cos x is sin x minus 13. Now, integration of cos x is a changed, and changed by here a constant. In a first case, the constant is a 0. In second case, it is a 7. In last case, it is a minus 13. So we take integration of cos x dx is equal to sin x plus c, where c is an arbitrary constant. It has infinite number of values. In first case, it is a 0. In second case, it is a 7. In third case, it is a minus 13. And this c is called constant of integration. So, integration of any function f of x is denoted by capital F of x plus c always. After completion of integration, we put constant of integration, and such a integration is called indefinite integration. As the value of c is not fixed, not definite, so the integration in which c appears is called indefinite integration. If the value of c is known or defined, then such an integration is called definite integration. It's called definite integration. And integration has a two types. One is indefinite and second is a definite integration. As this is a indefinite integration because we use c, and these are definite integration because in each case the c is a fix. In first case it is a 0, as initially we have given constant is 0. In second case it is a 7, as in initial case we have given constant 7, and in third case it is a minus 13. So these are the definite integration. This is a indefinite integration. In general, after completion of every integration, we put constant of integration c. So such integration are called indefinite integration. Okay. Now next, as you see here, one notation which you should remember, that is derivative of f of x is always change in function, that is f dash x. And now see integration of f of x. Integration of f of x with respect to x is a capital F of x plus c. So remember the notation. We define derivative of function by f dash x and integration of that function by capital F of x. Similarly, g of x is a function, then its derivative will be g dash x and its integration will be capital G of x plus c. Remember, we put constant of integration c after completion of each integration. Okay, notice the integration of f of x with respect to x denoted by I. Yes, integration is a process of summation. Always after completion of summation or adding number of objects, we get one object. So integration is always denoted by capital letter I, as it is a summation. You can compare with derivative. Derivative is a change of rate. It means it changes all time. So derivative can't be put into notation, or it can't be put as an arbitrary constant. But integration as a summation, we can put it as a arbitrary constant or capital letter I. So I is integration of f of x with respect to x, and which is a capital F of x plus c. Always remember, in examples integration start with I and end with c. Okay. Second note is a simple note. As derivative of f of x is a f dash x, then integration of f dash x is a f of x plus c. As you know, 5 square root of 5 square is a 5. As square and square root are reversed, so we get original 5. Similarly, derivative and integration are reverse process, so that integration of derivative, integration derivative get cancelled and we get the function of x only plus c arbitrary. As in derivative we have learned addition subtraction rule. Similarly, in integration we have this first rule, which states that two functions are in addition or subtraction in integration, then take separate integration of each function. You have to write correct way integration, as integration of f of x is written here by operating symbol of integration and multiplied by change in x. Similarly, gx has a separate integration, so we write here symbol of integration operated on gx and multiplied by change in x. Now, second rule is again simple rule. See, in second rule we have a constant and a function of x in the product. Remember this, only constant, product of constant and function is given, then constant take outside integration, as we did in derivative. Always constant we take outside derivative. Similarly, in integration, constant take outside derivative. In general, if number of functions are given in addition or subtraction multiplied by constant, here k1, k2, k3 are constant, f1, f2, f3, are functions. Take separate integration of each function by taking constant outside integration. Now we take one important note, that is integration of operator dx is always equal to x plus c. Similarly, integration of dt is equal to t plus c, and integration of dy is equal to y plus c. Now, integration of constant. As we learn in derivative, derivative of constant is always 0, which is a very simple formula. Now, we learn here how to take integration of a constant. As constant is here in multiplication of a dx, and dx has the integration x plus c, as we seen in first note. So, by rule of integration, constant take outside integration. Remember, if constant is in derivative, then its derivative is always 0. If it is in product, then we take constant outside derivative. But in integration, as operator has a integration, so we always take constant outside integration. So k take outside integration and dx has the integration x, so integration of constant is a kx plus c. As 1 is a constant, so integration of 1 is always x plus c. See the examples. F of ax with respect to x is equal to f dash ax into a, as derivative of function multiplied by coefficient of x. As integration is a reverse process, observe here what happens if integration of f of x is a capital F of x plus c. Always remember, derivative is represented by f dash and integration is a capital f of x. Now, coefficient of x is here a, then the integration of f of ax is a capital F of ax divided by a, as the formula of integration does not change, but it is divided by coefficient of x. In derivative, we take coefficient of x in a product. In integration, we take coefficient of x in a division. As integration of sine is minus cos, therefore integration of sine 3x is a minus cos 3x. upon 3 plus c. Integration of e raised to 2x is a e raised to 2x upon 2 plus c. Integration of cos 7x is a sine, as integration of cos function is a sine. So integration of cos 7 is a sine 7x upon 7 plus c. Integration of e raised to minus x is a e raised to minus x, as coefficient of x is here minus 1, therefore minus 1 plus c. And integration of cos of 3x plus 2 is a sine 3x divided by 2 whole divided by 3 by 2 plus c. Okay, and in this note, if coefficient if x is replaced by linear term of x, that is ax plus b, then as we did in derivative, similarly here in integration we take standard integration of function, replace x by linear term and divided that integration by coefficient of x. Now integration of sine 2x plus 3, as x is a linear, here 2x plus 3 in a sine function, so its integration is a minus cos of 2x plus 3 divided by coefficient of x is a minus 2. Remember, we have to put plus c in each integration, as we did it here in each example. Now integration of e raised to x minus 1, as here coefficient of x is a 1 and it is a linear, so its integration is e raised to x minus 1 divided by 1 plus c. Now 7x plus 4 raised to 5, this is a power function in which x is replaced by linear term of x. So by standard integration we take integration of this example, as increase degree of expression by 1. So 5 plus 1 6, 7x plus 4 raised to 6 divided by 6, as we divided coefficient of x, instead of that we take 7 in multiplication of denominator, that is in form of 1 by 7 plus c. Here is the same 2 minus 3x, here x coefficient is a minus 3, so and power is a 4, so its integration is a 2 minus 3x raised to 5 divided by 5 into 1 by minus 3 plus c. And finally integration of tan, actually integration of tan function is always log of sec x, if standard integration is given, but here x is replaced by linear term of 1 minus x having coefficient of x is minus 1, so integration of tan of 1 minus x dx is a log of sec 1 minus x divided by coefficient of x is a minus 1 plus c.